Okay, so let's do these two problems, and we can use the binomial table, or really the easiest thing is going to be to use Excel. Now, what we have to remember when we put the information using Excel into the Excel command is it always gives us the probability of less than the number of trials that we happen to be looking at. So, um, the Jones family was one of the first to come to the U.S. They had 7 children. Assuming the probability of child being a girl is zero point 0.5, we want to find the probability that the Jones family had at least 5 girls. Now, let's realize that at least 5 means they could have 5, they could have 6, they could have 7. Now, when we put something into Excel, though, if we put 5 in, for example, it would give us the probability of less than 5 girls, um, or really less than or equal to 5 girls. So we want, though, the probability of 5, 6, or 7 of the children being girls. But since Excel gives us less than 5, let's do the complement in Excel, and then we'll subtract what we get from 1. So the complement of having 5, 6, or 7 girls would be having 1, 2, 3, or 4 girls. All right. And Excel, if we put in a 4 for our number of successes, would give us the 1, 2, 3, and 4 probability, all of those together. So let's put in uh, the number of successes as 4, the number of trials as 7, and the probability of zero point 0.5 into Excel, and then we will subtract that answer from 1 to get the probability of 5, 6, and 7 girls. So just think, at least as always, the same amount and then what comes after, what's more. Okay, so let me go ahead and open Excel. Let's see. I'll open Excel. Oh, actually, I had it open over here and didn't realize. Okay, and we'll open a blank workbook here. And we're going to use the command equal binom. And usually this pops up and I just hit that. All right, our number of successes will be 4. Our trials will be 7. Whoops. Let's see if I can get back into it. There we go. Our probability is 0.5. And then it says cumulative, and we just want to put true. Close those parentheses, and that probability is 0.773438. Now, remember that I said that we want the complement of this because we want the probability of having 5, 6, and 7. So I'm going to do 1 minus 0.773438. And that is 0.2266. I don't know what it said to round to, so we'll see here in a second. So 0.227 or 0.2266, depending on what it wants us to round it to. Let's go back to the question here and we'll see. It didn't really say, so we could have put that whole decimal in there. All right, now, the nice thing about the second part of this is it's really asking for the first calculation that we did because we want to know what the probability of having at most 4 girls is. That is having no girls, having 1 girl, having 2 girls, having 3 girls, or having 4 girls. That's what at most means, that the maximum amount of girls we had could be 4, but we can have less. All right, so that's exactly what Excel gives us when we put in 4 as the number of successes. It gives us 0, 1, 2, 3, 4, all of those probabilities added up, the cumulative amount. So the very first answer that we got when we put it into Excel was actually the answer to the second one. So the 0.773438 is the answer to that second probability. All right. Now let's skip down to the other one you asked about. Number 5. Okay. A manufacturing machine has a 3% defect rate. If 7 items are chosen at random, what is the probability that at least one will have a defect? Now, at least one would be, we could have one that had a defect, we could have two, we could have three, we could have four, we could have five, six, or seven. Now the problem is that when we put a 1 into Excel, it's really going to give us the probability of 0 or 1, not the probability of 1, 2, 3, 4, 5, 6, 7 all added together. Instead, let's use the complement. The complement of having at least one defect would be to have no defects at all. All right, so let's calculate in Excel no defects at all, and then we will subtract that from 1 to get at least 1, to get 1, 2, 3, 4, 5, 6, 7, to get greater, 1 or greater, essentially. Okay, so I am going to put 0 in as having no defects as my number of successes, 7 as my number of trials, and 3% or 0.03 as our probability. All right, so doing the same thing, we'll have equal binom distribution, and 0 successes, trials will be 7, probability was 0.03, and cumulative is true. And that probability is 0.807983. Now remember that this is giving us the probability that none of them have defects. Let's go ahead and get the complement of that by subtracting that number from 1. Oops. And that is 0.192017, which is the answer to our question. And I hope that helps.